Most people would not think of screws, doorknobs, faucets, or scissors as machines, but they are. They are simple machines. Machines are devices that multiply force, enabling us to do things that would otherwise be very difficult or impossible. For example, how many times can you lift your fellow teacher higher than your head? How many times can your fellow teacher lift you? It doesn't sound easy, but it is. And it's fun too. When you and your friend are on a seesaw, that's exactly what you are doing. A seesaw is really a kind of machine called a lever. A lever makes lifting easier than it would be normally, even when lifting things that are heavy like your friend. The simplest kind of lever is just a straight stick or board and something to rest it on. Suppose you wanted to move something heavy, like a big rock. You can push one end of a strong board under the rock. Then, you can push a log under the board as close to the rock as possible. This will be the resting place or fulcrum. The end of the board near you will stick up. By pushing down or applying force on the high end of the board, the other end will move up, and the heavy rock, which we can call the weight, rises with it. There are three classes of levers: first class, second class, and third class. The familiar seesaw in a children's playground is a first-class lever. This is because the position of its fulcrum is between the force and the weight. A pair of scissors is a combination of two first-class levers. So are garden shears, wire cutters, and pliers. For a second-class lever, the weight or resistance is between the fulcrum and the force. An example of a second-class lever is the wheelbarrow, paper cutter, bottle opener, or a door that has hinges. Unlike first or second-class levers, a third-class lever has its force positioned between the fulcrum and the weight. Many objects can be classified as third-class levers. For example, a pitchfork is a third-class lever. Can you locate and label the fulcrum, force, and weight for each of these other examples? A shovel, a spoon, a broom, a baseball bat, and a fly swatter. Some tools are made up of a combination of two third-class levers like ice cube tongs, tweezers, and bread tongs. A first-class lever is when the fulcrum is between the object to be lifted and the applied force. A second-class lever is when the object to be lifted is between the fulcrum and the applied force. And finally, a third-class lever is when the applied force is between the fulcrum and the object to be lifted. People used to move objects from one place to another by dragging them around on sleds. But when something is dragged along the ground, friction slows it down. It did not take long before someone thought of attaching wheels to sleds. By attaching wheels to both ends of a pole, the wheel and axle was invented. The wheel and axle was such a successful invention that we still use it a lot today. Some wheels have teeth. They are called gears. Gears can make other gears move. They are very useful when force needs to be transferred from one part of a machine to another. Gears can make other gears turn faster or slower. The gears on a multiple-speed bicycle enable a cyclist to change the speed of the wheels. A large gear attached to his pedals turns a set of smaller gears on the rear wheel by means of a gear chain. The larger gears turn slower than the smaller gears, thereby varying the biker's speed. An inclined plane is a simple machine that can be used to raise an object to another level using less force. And in this demonstration, Edmond will show us how it is done.
Okay,
Edmond?
for this activity, we're going to use a wheeled car with some weights, a spring scale, 60 centimeter wood, and another 120 centimeter piece of wood, and a box about 20 centimeter high to support the inclined plane. First, I'm going to raise this wheeled car with some weight using a spring scale the same height as the box. About 4 newtons.
Okay, that's 4 newtons.
Okay. Now, we're going to use the 60 centimeter inclined plane first.
Let me hold this for you.
Then we're going to measure the force needed to lift this car up to the end of the inclined plane. As I pull the car, spring scale reads about 2 newtons. We're going to use the 120 centimeter inclined plane. Can you please hold this part? And I'm going to pull the car and measure the weight or the force needed to lift.
Yeah, the reading is 1 newton.
Now it reads only 1 newton.
Yes.
So we use
Could you please let it move until it reaches the end? What is the reading?
1.
So from these 3 measurements that we have made, without using any inclined plane, using the short inclined plane and using the long inclined plane, we can infer that indeed inclined planes lessen the force needed to lift an object. But the distance traveled by the object is longer. The shape of the inclined plane can be found on tools that cut and slice. This is a variation of the inclined plane that is called a wedge. A wedge is often used to split things. Its thin, sharp edge can pierce or push into things easily. Then, the thicker part of the wedge can push through and spread apart. A carpenter's chisel, a kitchen knife, and even a tiny needle have sharp edges that are wedges. The winding edge of a screw is called its thread. It is this winding edge which grips and holds. So a screw is useful for holding things tightly. In some cases, a screw works better than a nail, which has straight sides. A screw can also be used to lift things. A scissor jack for lifting a car uses a big screw to provide a force for a pair of levers that push the car upwards. Do you know that a ship's propeller is a kind of screw? The propeller blades act like oars, pushing against the water behind them. When a screw is used to lift or push, it is converting a turning force into a straight line force.